Welcome back after your long break. Pushing right ahead. We're going into lecture number 2. So we're done with the baby steps. Now we're going to take bigger steps, hopefully. And I'm going to show you where to get some source code examples as well, which is going to be good. I can't talk about Java without talking about the object. So the focus of lecture number 2 is on object-oriented programming, looking at the concept of the object and how it relates, and how object-oriented programming is different from procedural programming. Object-oriented programming, as we can see on the item on the right, if we have a program, we would have an employee object, and then on the left, if it was a procedure, it would be something like a date, a function, something. So a unit in a procedural programming is sort of like the function. A unit in the object-oriented programming is a class. So all you're doing when you're making Java programs are creating and writing classes. So that's all you do. And one class is just like another class. You have one class, however, that you call the driver class. And that class is going to drive the program, which is why I call it, I don't even think it's technically called a driver, but a lot of people call it the driver. So some people like to call it main, and they actually call it, like they label it main. Some people label it driver. I don't like to do that. I like to name it the name of the application. So if it's Hello World, I'll call it Hello World, and I'll put the driver in there. But the driver is the one that has main. And so those people who are from a C++ background, you know main. Main's in every program. Main's not in every program in a Java environment. It's only in the driver in the Java environment. And main starts the execution, and I'll show you some quick and dirty ways of compiling and creating programs using multiple files. Because the first thing that Java developers kind of have to start getting used to is the fact that it can't all go into one file. You got to separate everything. And even if you put it all into one file, when you compile it, it goes out into different files. It's never going to be in one file. So you kind of have to move past the one program, one file. This is my program. It's a series. It's an accumulation of components that are going to create this program for you. So the class is the object. So from a programming language perspective, programmers talk about classes. Classes don't exist when the program is running. The class turns in, there's the blueprint of the object, it turns into the object. We don't actually have objects. We have instances of objects. So the first thing you do is you create a class, and that's the source. That's the template. The class turns into the object. In order to use the class, you make an instance of the object. So once you get, and then that's all you're doing. There you go, we're done. That's it. That's the entire course. You just make instances of objects. So the design of how you create the object is kind of where the talent comes in. What are you putting in the object? Object refers to the, class refers to the blueprint. Object is the instance of the class when it's created. Each object has a class which defines its behavior, data and behavior. And then so most people who are brand new to object orientation usually have this thing, well, what's an object? Well, great. Now I know what objects are. What are objects? Well, everything in the real world is an object. The chair is an object. The board, my cup, is an object. So you take the environment that you're programming. Say, for example, we want to create a student registration system for ITU. The first step in the object-oriented design is identify the objects. So I have students, I have classes, I have teachers, books, all these things turn into separate objects. And then you write a class to implement each one of the objects. Then you write a driver program to make instances of each one of these objects and have these objects interact. And then that's when you start looking at me and going, what do you mean interact? This is a program. This is source code I'm writing. How am I going to... Well, objects have a life. Objects come to life and they interact with each other, which is really interesting, actually. So objects, by nature, have two components to them. They have, well, actually there's 3. The classical method of discussing UML, well, it's actually, now we're getting into UML, Unified Modeling Language, which is the modeling language that is used as a basis for object orientation. So everyone knows, whether you realize it's UML or not, you're learning UML because it's the object-oriented foundation. And it's nothing more than just a notation. So according to UML, objects have 3 components, and those are identity, states, and behaviors. So every object has an identity. So when you start designing this program that you're creating, you have to identify all the different objects. So if I was talking about the student registration system as an example, I'd say, well, classes, students, books, all those things I named off a few minutes ago, those are all objects. And the identity ends up being the name. So that would be, class, my class, or actually, let's just call it class. And another weird thing, and I'm kind of going to talk ahead a little bit, and then I'll cover the slides. But when I start remembering stuff, I'm like, yeah, I better mention this, I better mention that. Another thing I probably should mention is that all classes, when you create them as objects, start out with a capital letter. It's C. Let's say I'm going to create a class, I'm going to call it students. It would be a capital S. T-U-N-T, whatever, .java is how I would call it, with a capital. Why do you do that? Well, it's actually kind of it's like, when you learn programming in C, they always teach you about comments, and they always teach you about how do when you create variables, giving them meaningful names and all these other things, it's just one of those best practices. You'll notice when you start looking at other people's Java code, you can tell the professionals from the non-professionals. Professionals will capitalize the name of each one of the objects. Why? Because it's a person, place, or thing. It's an object, so it's always capital. I don't know why that reasoning came out, but it's a best practice. You can have a class with a lowercase, and you can call it employee with a small e, and nobody will say anything. But if you want to do best practices, you capitalize it. And then what ends up happening is you identify the objects by their identity. So 5 years from now, you go back and you say, I need an employee object. And you go, well, here's one that says object 1, object 2, object 3, object 4, oh yeah, where's my employee? So it's self-identifiable, but then it also creates like a world. Now you've got employees, teachers, students, staff, all these things, and you have like beings, like objects that you reuse, because part of object orientation facilitates reuse. So you create the object once, you compile it, sits there in your repository of objects, and you reuse the object every time you need an employee, every time you need a student or something. So that's the first component, is its identity. And then we have its state. So how are you going to record a state of an object? You have these variables. So non-object-oriented languages, procedural languages, they call them variables. Everyone learns about variables. And I'm going to assume most of you hopefully have had a programming course before. If you haven't, pick up a Deedle and Deedle text. He'll talk about variables. But in object orientation, they call them data members. They're data. So the second component of the object is data. Which is state. Yeah. So what's a state? Well, color. If I were an employee, let's talk about an employee object for a second. If I were let's talk about person. Let's break it down a little bit. If I were a person, some of my states would be sitting, standing, maybe. Would be name. What is your name? That's your data. So your state and your data is sort of the same thing. Your name, your social security number, your student ID number, those are all different things. And some data belongs to students, some data belongs to people, some data, and you actually, believe it or not, it sounds kind of tedious. You sort of have to figure out what belongs to what. Because what we're looking for is to create a hierarchy of these objects. Because the interesting thing is if you keep object identity down to a single identity, you don't create schizophrenic, multi-personality objects. Because if you do that, you're going to have a messed up world. You're going to have a bunch of mentally ill objects who think they're something that they're not, which is really bad. So you create a mentally healthy environment for which each object only has one identity, and you build the objects on each other. And that's where you get inheritance from in a concept. So we have a person as an example, and a person, if you were to, let's let's just start at the hierarchy at the person level. I could go back through Darwin down to the ape if I wanted to, but I'm just going to start with a person. And I say, well, a person can be a teacher, a person can be a student, a person can be an employee, a person can be a staff member. So from person, we call that a base class. We call that it's still an object. Everything's an object, so it's a base object or a base class. And then we build classes upon that. And we say, well, we'll take person and we'll turn them into 5 different other objects because they're all a person. And then we figure, let's create an employee that's a person. And then so we create an employee. Let's say, make the employee the janitor. So now we have yet another hierarchy. Now we have a janitor who's an employee who's a person. But then we also have a teacher who's an employee who's a person. And a student who's a TA. Maybe a TA who is an employee, technically, and who's also. But we don't have students who are TAs, so we have, well, we could. It depends on how we build our hierarchy. So when we're designing our applications that we're creating in Java, we're thinking about the hierarchy. We're creating objects with single identities, and we're building it, and because we don't want to reinvent the wheel. So if we have a teacher and we have students, and they're all people, and they're all coming from the people object. Things like the name of the person, the social security number of the person, belongs in the person. And then a student maybe has a student ID, a teacher has a faculty ID, and we keep the data associated with the object, and we don't repeat it, which is the reuse. It's how the hierarchy is developed and promotes, like, for each new object you're adding to it, and they call it a specialization. You're specializing. So now you've got an employee who's also, ooh, look at that, the employee's an accountant. So now we have an accountant specialization, and then we have a janitor specialization. Kind of like the real world. Well, you take a class, you learn how to program in Java, and then you become a Java developer. Well, that's different than a person who takes a class in CPR and ends up being a medical person, whatever, first aid person, Red Cross person, whatever. Little different specialization that goes on. So that's the terminology that's being used in terms of the hierarchy. Last component. So we got the identities, we got the states, and that states are the data members, as I mentioned before, the data that we're keeping information. And now we have the behavior. So identity, state, and behavior. Well, what's the behavior? Students take classes. Employees get raises. Well, hopefully. Employees get fired. Employees get hired. All of the different things, the behaviors that the object performs in its life are the behaviors, also called member functions. Why do they call them? The word member is used consistently, and you'll see that used throughout a bunch of textbooks. Because members belong to something. So an object has membership, has data members, and has member functions, because those are its states and its behaviors and the things that it owns. So not that it's an ownership kind of thing, it's more like a belonging or membership kind of terminology. So you'll hear it all the time. Sometimes they call them, and this is the interesting thing, when you start reading all of the books, you go Google and you find yourself, that's why I like Deedle and Deedle. He's pretty consistent. That book is pretty consistent in terms of the terminology, and it uses it consistently. Because here's another thing. So we have messages, methods, data members, all mean the same thing. So depending upon what book you're reading or where you see it, it's sending a message. We're invoking a method. Isn't that a data member? Or member function, or what is that? All the different terms. Because there's no consistency. Object orientation is not a standard. It was developed by developers and continuously changes by developers, and the terminology was made up by developers, and everybody's got their own idea what they want to call it. I hate the word message. But UML people love messages. Programmers don't think about messages. They usually think about functions. So member functions. I like to say member functions a lot because a method message member function is a function. And because how are you going to get behavior? You're going to implement it somehow, and you're going to implement. Data member is pretty easy to think about in terms of the implementation. We have data variables, so the implementation. Member functions is a function. So we have a function that we create. And then you get into this whole philosophy of the accessors and the modifiers. Because people take this to an extreme and they go, okay, well, what kind of behaviors do we have? Well, we can access data, and then they call these things accessor members. I don't know. Or then we have modifier members because they modify the data. And then I simplify the whole thing and I go set or get. Are we setting data or are we getting the data? Which is the accessors. To access it is to get it, and the modifier is to change it. Modifiers. So set or get. So when I start labeling stuff, naturally I'll go set name, get name. And just the same standard convention you learned in C++ perhaps. You can't put spaces in the middle of names, so what do? You change, you play around with the capitalization. And here you get the lowercase g, G-E-T, and then you got the uppercase N, so you can have the two words read together. There's a name for it, and I can't remember what they call that. There's a label. I don't know, somebody probably knows it. Where it's a theory that people use. I don't know. Anyway, so you get name. Camel something. Yeah, cameling. Something like, yeah, you're onto it. That's it. Yeah. I don't know if it's camel or camel something. It sounds close. Camel letters? Yeah. Camel case. Camel case. Yes, that's what it's called. The lowercase g, because you start out each new word with a capital, so you can differentiate the two. Yep, there you go. I learned something. Remember something new today. Alright, so what I'm going to do is kind of go through the textbook definitions and then give you all the different options. So here we have our class members, as I was mentioning before, and I talked a little bit ahead on the slide. Class can have three kinds, and you're going, well, I just said there's two. Now we got three kinds. Technically there are three kinds. What you're going to do in this class is two kinds. You're either going to put data members in there, and here's more vocabulary for you. Sometimes they're called fields. The fields, I don't like fields either. Sometimes I have a tendency to call them variables because that's really what they are when you're creating them. However, that's really wrong. That's procedural language talk. That's not object orientation. So then I correct myself and then I say data variables, data members, or I just say data. But yeah, I'll slip up and I'll call them variables. They determine the state, the methods. Methods is actually kind of acceptable to me. Methods, member functions, and they execute the code. And then we have this nested classes and nested interfaces. I'm going to talk about interfaces after the midterm probably. I'm not going to hit you with interfaces until after the midterm. And then I'll talk about nested classes at that time as well. But this is stuff you can put inside the class. Think of it this way. But right now we're going to talk about data members and member functions is what we're putting inside. We're going to forget about interfaces and stuff. So here's our sample class. It's a pencil. Nice pencil. So the pencil's got a few things on it. And I mentioned before, I said each one of these objects gets instantiated. I didn't actually use that word, but that's the word you're supposed to use. Instantiated, if I'm even pronouncing that right. I can't even pronounce. So I say make an instance of it. That's instantiation, if I'm saying that right. So each pencil, when you make an instance of it, becomes its own object. And we can have many different pencil objects. So what I'm going to do is, kind of about halfway through, I'm going to start cutting and pasting and start putting this into Eclipse. So I can actually show you what this is, what's going on with this. The same way we did Hello World. But I want to go over some basics first, and then we'll see it come to life. And I'm going to show you a couple tricks with compiling it as well if you do it the manual way. Because some students still like to do things the manual way. So here's our pencil. And here's another thing that I differ with. So you'll see it in books and you'll see other people doing it the opposite way around. I come from C in the old days when all the variables were defined in the beginning. You know, like you started out with main and you had integer I, integer j, and you put little comments there. That's where I come from, so I always put the data up front. I always put those data members first. Not like C++, it's not organized by public, private, protected, all that other stuff. No. Instead, on each individual line, you got to give it, and this is referred to as the access method. And for right now, let's just talk about public and private, which is going to be our access methods. And our access methods is the form in which we're getting at anything. Even the class, although it doesn't say public class pencil, we can use an access method with the class name, with the data members, the member functions, with everything. Even abstract classes, interface classes, which we're going to talk about after the midterm. So you're going to see it in every one of Deedle and Deedle's source code examples the opposite way around. He puts the members underneath, he puts the data underneath the functions. I don't like that. I do it the other way around. And I find most students can understand it better the other way around. I don't know. And just like C++, this breaks the rules a little bit, but if you're familiar with C++, and I only say this for the benefit of the C++ people, if you don't know anything about C++, this is your first language, don't listen to anything I say about C++ because it's not going to make any sense to you. But just like in C++, what was I going to say? You want to make the data members private and the member functions public. This is wrong. Don't look at this as the model class. This class has got issues. Because these data members, they should be private. And in C++, you go private, and then you go colon, and then you go underneath, you list out all these data members. Nah, Java's a little tedious. Every line's got to have the access member. You can't do it the same, you can't group it the same way. And the reason why you make the data private and public mean two different things. Private is only visible inside of the class. Only accessible inside of the class, which is why they call it an access method. If it's public, it's accessible anywhere you want. Dangerous. Because somebody out in your driver program can go ahead and change the pencil color by going, and then we'll look at the dot notation in a few minutes, but my pencil dot color is equal to blue. And it can violate the integrity of the class. So in theory, you make this stuff the data. You guys see that? Oh, that's good. Glad I fixed it then. You make the data. There we go. You make the data private, and you let the functions that you're creating, the data members, modify the data. And here's an example of what I'd call the modifier, but I use set and get. So this one says set color, and this is a function, just like an old C++, C, whatever function. Those are the methods. And it's taking on one parameter, it's a string, it's a new color, and it's going to say color is equal to new color. Biggest classic mistake, biggest mistake C++ and Java people do when they first learn about classes and implementing classes. In this function that we're all familiar with, and that we were drilled in with procedural programming and imperative languages to say what's inside of the function stays in the function, and the scope of that function, and you know, like we send something to the function, we return something from the function. All these functions have to have returns, and all they have to have data types, and you gotta like mind erase all that stuff because all the rules get broken. As an example, in here we already know about color. We don't want to, and I see this constantly, we don't want to go string color in here. If we do that, now we have two variables, two data members that all say string color. If you don't get an error message, which I don't know if you're going to get an error message on that or not. It depends on how sophisticated the compiler is these days. But in the old days, you got an error message. Some of that stuff went away. But you're going to have two. You've redefined it. What you're doing in the member functions is setting and getting and changing the data members. Don't redefine it. Don't create a new variable. Never create a new variable inside of the member function. It's another one of those things, one of those best practices. You can do it in here. It will work, but it breaks the the rules of consistency in terms of where you're going to find the standard, where you're going to find something. You want to put them outside. You want to put them somewhere where they're visible. And here they're hard to find. But I could leave this off and put string color is equal to red. And then I could use it in here, and I could use it in something else. The scope is global for the class. So what happens inside the function happens everywhere else too. There's no, like, what goes to Vegas stays in Vegas, which is what they tell you with the functions. Not in C++, I'm going back to C++, not in C++ or Java, actually. It applies to both. Okay, enough said on that. This is bad practice too. You don't want to declare and initialize a variable outside of the member functions. You want to use the member functions to manipulate all data. So that's bad practice. That should just say string color and leave it alone. Don't initialize it to red. Because what you really want to do is use this thing called a constructor. And I'm going to go far ahead here. The constructor, it's a member function that you create. We're going to see one in a few minutes. Actually, we're not going to say it till the next lecture. Where it automatically, every time you make a new instance of the object, it runs automatically for you. Why do you want to do a constructor? Because you can control what happens with each new instance of that object, and it's in the control of the object. And you can override the constructor with inheritance. So each new object every object can have its own constructor. All the constructors can go off, and you have a sequence. And I'll go through all this stuff next lecture. Bottom line, if it's not in the constructor, you can't control it. We can't control this. Every single time one of these pencils gets created, the color is going to be set to red, regardless of what we've done to it elsewhere, which is not desirable if you're trying to turn things into other things and you're trying to make this pencil a ballpoint pen or something. You're really changing the concept at that point. So that's bad practice. These are just your normal data types you normally see. Get a Deedle and Deedle text if you don't know about data types. Data types of void are encouraged. Why do you want to return something? See, that's the other thing they teach you in imperative programming languages like C, C++. They drill it right from Hello World, where it's integer main, return 0. They drill it into you, and then they say, oh, forget all that stuff too. It's okay to have void. In fact, most of your sets are void. They're not returning anything. It's not going to return anything. In fact, your constructor must be void. It can't return something. So, get used to the concept of void is okay. Void is good. Void is your friend. So, what we have now in the lecture is going to catch up to where I've talked to so far. Our field declarations, these are declaring variables. Our initialization is happening inside of the member functions. We have different access modifiers, which are called access control modifiers, the formal word for it. We have a static and we have a final. Static is interesting. We have static. Do we have static in here? We don't have static in here. I think we have static in the next one. Do we have static in here? We have static in here. Here's static. You guys were saying it was in the previous one? Am I going blind? Oh, static! We do have static. Static. Lovely keyword, static. And you know C++, they use static, so things don't change. Alright, so and people are drilled into, oh yeah, static. You only put that on a constant static, make it so it doesn't change. Java is a little deceiving. Here it takes what could be a member variable, turns into a class level. So it's the difference between instance variables and instance you have static everything. You can have a static method or you can have static data. And it takes it from being part of the instance of the object to being part of all the objects at the class level. It kind of breaks the rules a little bit. Because as I was saying before, we have a driver program where we make an instance of pencil, we call it pencil 1. And we have pencil 2 and pencil 3, and each pencil has its own color. If you make this, as an example, we make this static, then we can set the color for all pencils at the class level. Instead of calling the instance and saying pencil1.color is equal to something, we say pencil class.setColor to blue. And then all of a sudden, all of those instances that are out there, all their color gets changed to blue. It's I always refer to the example, and people, I don't know if this is politically correct or not, so forgive my insensitivity to religion. However, it's kind of like playing God. It's like someone coming out and going, all you people, do this. And then all the people do. Then all the people conform. This is the control that static has. All of the objects will have the same, will have to do the same thing, will have the same behavior, will have the same change done to them. And you're wondering, well, why? Because, well, okay, outside of playing God with your objects, you know, definitely that brings up some psychological things about your objects. However, it's good when, and used in this particular example, what do you need to set an ID? So each pencil has its own ID, so you can keep track of it. And so each new pencil that gets created uses the existing ID, and the ID gets updated for everybody. The number, the counter number, gets updated for everybody every time a new instance gets created. So inside the pencil class here, next ID is equal to 0. On the constructor, we could say, well, next ID is equal to next ID plus plus. And so every time an object gets created, it updates next ID for everybody. And so we say, well, employee ID is equal to next ID. And then all of a sudden we have an instant way of controlling how many objects we've got, what kind of IDs we're giving these objects. And you know, it's like playing God. It allows us to kind of go through and control all of the objects at a class level instead of at an instance level, which is what that's about, which is what that static's about. And I'm going to save final for after the midterm, but it's another kind of one of these tricks that you can do. I'm not going to talk about final because that's a whole different concept. More about field operators. Here's our access control modifiers. Talked about public and private already. We also have package and protected. Package is going to give us accessible classes in the same package and the class itself. It's going to give, think of it more of a scope thing. A package is a directory. So we can put, and this is the other thing that brand new Java programmers hate, because it's different than C++. In C++, we include everything. In fact, that's another thing they drill into you. You know, include this, include this, include this. All these .h files, all these .c++ files. Scratch all that out. There's no more includes. But we can import packages. And all we're doing is saying it's different. It's not libraries. We're not we never actually include anything. Instead, we say, look in this directory, look in that directory, look in this directory. It's because you're not going to be able to find what you need, because the engine, the JVM, is going to go, where is this class? Well, if it's not in the same package, you got to include the package that it's in if you're going to make an instance of that object. Otherwise, it's not going to know which object you're talking about. So, think of package like a directory, and I have an entire lecture on packages and doing that, but it's a more advanced kind of project thing. That's going to happen after the midterm. Not going to happen yet. Protected. Protected members are accessible by classes in the same package. Different than protected that's used in C++. Protected, it's private. What is it? It's private to the public, but public to inheritance. So in C++, you know, everything is public. And in fact, the same rules apply with Java, actually, so it merits a little bit of review, I guess. In the driver program, if it's public, anything, free game. If it's private, only in the class. If it's protected in the class, it's private. No, yes. And then in inheritance, it's public. So protected is kind of like yellow, green. Was it yellow, orange, green? No, red. Yeah, the stop signs. Green, I know I drive too. Yellow, no. Yellow light's in the middle. Green, yellow, red. So protected is yellow. It's kind of in between. It's like, it's private to everybody else except for inherited classes. So it's in the middle. And right now, you can actually leave it out, which is the interesting thing. You can't leave it out. Can you leave it out in C++? I think you probably can leave it out. I don't know. I know you can leave it out in Java. We're going to see it happen. So here's our pencil. In our pencil class, we're going to create a pencil, another class that we're going to create, and then create pencil. We're going to create a pencil. So pencil P1 is equal to new pencil. I'm going to go through that in another example coming up soon. We go P1.price is equal to, can't do it. It's going to give us a message because we can't set a static data member from an instance. We can only set it from a class level. So we would have to say pencil.price and change the pencil price. Okay, so here's our static. Only one copy of the static field exists, shared by all objects of this class. So in an instance variable, we have every instance has its own value. So if you just remember it that way. And then in a class level, there's only one for all instances, which is what that point's telling you. Can be modified directly from the class itself, and access from outside of the class must be preceded by the class name as it follows. So here we have pencil.nextID. Great opportunity to talk about system I/O. So we have in C++, we have cin, cout, we have printf, scanf, and all those little lovely things in C. We don't have any of that in Java. So now we have system.out.println, and this is the first object that you create. Notice the object has a capital S. We're running a method out that is a member of system, and we're running another method, println. We could say print. Println actually puts a line at the end of the line. I mean, line return puts a new line underneath it. Print is just going to print it out. There's like, I don't know, maybe about 7 different variations of this, believe it or not. Everyone just does this. In fact, that's the interesting thing. There's so many different methods to run. Like, which one are you going to run? It's like until you find a need or use it, you don't really learn it. For right now, you can just, so this is how you do output. This is cout. Different. It's not running a function. It's not running it's different. You don't have any operators to overload. You don't have anything. You just have this method you're running, println. It's going to be a system out. So it's an object itself. So here's our pencil class, and what we're going to do, actually this is probably not a good, this is a poor design. Yes, I know it is a poor design. Let's stop for a second, and I'm going to show you something else, because it makes no sense to show you PowerPoint slides on how to program something. It's better to actually show you how to program something. So that's what we're going to do now. Another note to remember, and you can go through that lecture. I'm going to go back to the lecture to recap, summarize a few things as soon as I get done with the programming example. And if you're wondering, we're probably going to go to lunch after this section. So if you're getting hungry, we will be taking a lunch break soon. So, let's see. Come on. There we go. I'm going to make it a little bit smaller. Course materials. Okay, so I mentioned before for the programming assignments, you're going to find it all here. You're going to also find examples that go along and support files that go along with the programming assignments. You're going to find them in the assignments category. You're going to find the tutorials in the tutorial category. These are not lectures, these are not video recorded lectures, they're actual tutorials. Well, you're going to find the way bottom of the screen, the last box on the bottom of the screen here. You're going to find lecture number 1 samples. This is a zip file. So you take it, you copy it, and it's going to show you some nifty stuff. Just put it on the desktop. All of the lecture examples are in this category, under lecture examples. I will inevitably have 1 or 2 students who send me an email, where can I get that source code from? This saves you from having to cut and paste off of the PowerPoints. It's actually all put together for you. We got all the stuff for inheritance. We actually got a lot for inheritance. We got all the lecture examples are in here. So I've downloaded it. Instead, so I don't have to cut and paste. And stick it over here. Actually, I think I have it over here already. Simple. Let's see. Let's extract it. No, I didn't have it. That's good. Opened it up. Now I got hello world. I got all this stuff, right? I could use it like this. I can go to the DOS prompt, to the terminal prompt, and I can use it just fine. Or I can go back to my favorite program, Eclipse. And then you're going to need to know, how do I use them in Eclipse or not in our projects? Let me show you something that's really easy, because if you just look at the file without a project, it's not going to compile for you. It's not going to work. Why? I don't know. If I were to rewrite this program, I'd make it so you can have another category with just source files that you can just play with. Instead, let me get rid of this guy. I'm going to remove him because I'm going to recreate. Delete. Let's just delete him. Delete it. So actually, word of caution. When you create projects in Eclipse, it creates a directory in what's called the workspace. There's a workspace folder. You can leave it in the workspace and take it out of the IDE, or you can take it out of both. That's what this little option is telling me here. And it says, delete the project contents from the disk, cannot be undone. Yes, I'm going to delete it from the disk. So now what I'm going to do is create a new project. I know I just did this, but I'm going to do it I have a reason for doing this. I need to show you how to import. And I'm going to call this one Lecture 1. It doesn't really matter what you call these things. And it doesn't really matter, all the other features doesn't really matter for what we're doing. And then we have our blank everything, right? But then I have all those beautiful examples I just downloaded that I want to use. So instead, this is the weird thing too. This interface, as I critique it, I could use a few different changes. In order to use those examples, I've got to load them into a project, so I import them. So I click the import option. And then this interesting thing. So what do I want to import? Do I want to import a jar file, which I can do, or a zip file, archive file? Is it going to be existing projects into the workspace? No, I'm going to do file system. And I click on next. And then I browse to the file system location that I want, and I go. And then I get the email from the student. Can't select it. It won't let me. Because everything else in Windows works this way. You should be able to select it, right? Doesn't work. Instead, you got to go out here. This is I would change this to, and then you have to select. Okay. You can't select the files like that. You have to actually use the prompt for it, and then finish. That's one of the things I find irritating about this. And then I go, here they are. Here they are, no problem. So interesting thing as well. Let's say, for example, and I called it main. This is good. We have main. Main's going to work with, this is inheritance, so you don't know this yet, but you're going to get this after lunch. It works with all these other classes and things. We have boss, we have employee in here, we have boss in here, we got all this stuff. But notice at the top, I don't have any includes, I don't have any packages. I don't need packages. I don't need to use packages at all. If it's all in the same directory, all in the same location, don't bother with it right now. Don't complicate life. I have so many students who are so worried about the packages right at the beginning. Not worth it. Not worth it. But let's go through the pencil example. I was wondering if I have pencil. I thought pencil was in here, but it's not. So instead, let's just create one. So now we say, well, I got the wrong file. So I'm going to say, well, I'm just going to. Here's the other thing too. When you start opening up, we get new tabs for each one of the files. And then lo and behold, I'll end up editing the wrong tab. So I like to close the tabs. Just because it's not obvious, it just looks like the text file. So I start writing the wrong method in the wrong file. And I go, oh, what is wrong with that? So here we're going to do, what I'm going to do before the break is I'm going to create a pencil. I'm going to create a main for the pencil. I'm going to show you how you can have multiple mains, and multiple everything, and how you can run stuff. quite easily. And it's how flexible this is compared to C++. So, and I'm just going to cut and paste. So I'm going to go, so I don't have to type it. So I'm going to go new. You can create, for our purposes, the only thing we really know what to create right now is a class. It's the only thing we've talked about. So I'm going to go new class. Just like that other example before, I'm going to call it pencil. And I'm going to press finish. I'm going to worry about all the other details soon. And I'm going to say, here's my pencil class, right? And I'm going to go back to the lecture. Actually, let me make this smaller again, so I can just quickly just go through this real quick. Method overloading. I think we're going to, this is lecture 2, wait a minute. No, we're on lecture 2 anymore. Hold on one second. I got it. Yeah, there's my pencil. There we go. I think I got to make this bigger for me. I can't see it. Let's just do this. And then we're going to create another class called create pencil. So there's my pencil. You can do it this way if you want. Or you could cut and paste and just put the body in there. And you're going to look at this and you're going to go, oh, this is a good example. This is actually a good thing I did this. Here's the other problem with Eclipse as well, especially when you start cutting and pasting, because that's what new programmers are going to do. They're going to cut and paste, check out examples. And you're going to go, well, what's wrong with that? It only supports ANSI. Yeah, this is like Notepad. It's a text file. And I cut and pasted this in here, but if you notice my quotes, they're in a different font. It's the font. If I notice this, I go, well, this is the first indication that I have a problem. And this is the other reason why I kind of like Eclipse. If I hover the mouse over the dot, it says syntax error on tokens. Delete these tokens. If I do that, I can actually automate the process. I can go, yeah, delete the tokens. Well, it usually gives you an option. We'll see it in another one, I guess. If I put the right token in, it fixes it. Here we go. This is what I was looking for. So I put I fixed part of it, but I just didn't fix the closing parenthesis. And I'm doing this kind of to show you the differences. This is the one it wants. This is the one it got. And you're going to go, well, isn't it the same thing? It's not ASCII text is what the problem is. So you cut non-ASCII text from a PowerPoint slide or from a Word file or for something, and you put it in here. That's why you don't want to use anything outside of a Notepad or a text editor or a Text Wrangler or something. And it gave you the wrong font. So here's the other thing, too. You can go over here, click this one, or hover your mouse over here, and it gives you suggestions. And if you click on the suggestion, insert missing quote, because right now I only have one quote, it puts the quote in for you. But this particular quote made an error. Here because it didn't do it correctly. So I'm just going to manage. Sometimes the automated kind of, this is, this will help kind of thing. Kind of works, sometimes it doesn't work. And we'll see it. I like to do it only because sometimes it makes some really good suggestions. Sometimes it's really wrong, like this one, for example. This is not red, it's yellow, which means it's a warning. So I can remove price because I'm not using it. And why would I want to remove it? I'm going to use it in the future. I'm just not done. So that is a little bit irritating. So you can actually suppress the message. That's what this is. Add a suppress warning. I just did that, and there's a little warning here. This will not affect the compilation of the code. It's a message, it's a warning. To suppress it, why bother? I don't know. I always leave them out. And I just leave it alone. Just because it's easier. And you don't actually have to have spaces in between any of this stuff. So now I have a full running class. So if I go like this, and I say build, well, build path, I don't want to do that. I want to run it. Actually, I want to go back up and pick the right one. Pencil. I want to. Wait a minute. I have to save it. Here's the other problem as well. In order to run it in this particular example, it doesn't know what it is because I haven't saved it. So this is another problem you're going to run into. It's probably a good idea that I did that myself and ran into the same problem myself. until you actually put something in here, we don't know if it's a class, if it's an interface, what it is. So we don't know how to run it. Where it said run configuration, I was going to go through, analyze my empty file because I haven't saved it yet, and tell me what it is so we can run it, because it doesn't know what it means. It is. So the easier method is to actually save it. So here I'm going to close it and save it at the same time. Say yes. Now when I go to run it, it's going to come back. And when I run configuration, oh no, let's go back up here. Why is it not going to run it then? Well, I wanted to run it to show you that it's not going to do anything. It's not going to allow me to run it because I don't have a main, is what the problem is. However, and it doesn't know if it's an application or if it's an applet. Out in, let's go out here for a second. Out in the terminal prompt, I just want to show you something real quick. So although this appears to be a hassle to demo, it's a worthwhile thing to see. So I'm going to save this out in my terminal window. I'm going to save it as pencil. Java. It's out there in bhacker right now. So let's see. Pencil is in here. Yep, here's pencil. So I go Java C pencil. And it should come back and not give me anything. Here's what I wanted to show you actually. You can do this once you have it saved and once you actually have the program put together. It wants to run a main. It wants to have the driver program, but I don't have a driver program. But there's nothing wrong with the class. I can still see what happens. I could still type in Java pencil. And it will still run. The only problem is it's going to come back and it's going to give me this error message. So rather than Eclipse giving me this error message, it just won't give me the option to run it because it's not runnable. No, you don't have to. It will say, well, that was in the workspace directory. I put this out here so I didn't have to do the path. I cut and pasted it and saved it. You can actually take these files, but I'd have to go out and look for them. You could run the file in terminal. I have to find the directory, and I don't know where this directory is. That's why I created it again.
So we have to create in our, if we have to work out in our terminal, then we need to go to the text editor.
No, you would go out. Here, let me do it. I was being lazy. You'd go to your computer, and you'd look for the files. It's going to be in Workspace, and I'm trying to remember where Workspace is. But the file's out here. I could go into Terminal, go and change the directory to the Workspace directory, change to the project, and then run it if I wanted to. I don't have to use those files inside of Eclipse, and I don't have to recreate them. Is a Java file is a Java file. Oh.
For the first time, when we were doing the Hello World, I couldn't see the Java file. And when I did I couldn't see that.
Really?
Is there any part that we have to set in?
See me at the break, and I'll look at your computer and test it for you. Anyway, out here there's a Workspace directory. You might actually... It might be... okay, I don't want to waste time. Alright, out there's a Workspace directory, and you can run it from the Workspace directory. Let me finish my little demonstration so we can go to lunch. So, we have this program, and I'm going to fix the error because I don't want to really demo this error. I'll demo the error after lunch. But if I, for example, come out here and go back to my text editor here, and let's say I want to do new, file new, text document, and I paste this in here, and this is going to give me an error message, so I'm just going to comment this out. Instead, actually, you know what, I'll just print I'll print the price. What do we have in there? Color. I'll make this bigger in a second. I changed the example a little bit just to print something out so we can see what's going on. Because there's something important I want to kind of show you, or illustrate to you, so you get the point. And I'm going to save it as, what's it called again? Pencil? Create pencil? This is why I do this. There we go, create pencil. So now if I go out back to my terminal prompt, I should see both. I have pencil, and I have create pencil. Oops, but I didn't put a Java. Oh, okay. Oops. All right, hold on one second. Java. I didn't put the Java extension on it. Okay, I do have a point. I'm going to illustrate very soon. Let me remove this other one. Create pencil. All right. I'm going to remove Java. Oh, class. Okay. We have two files that are running it, the driver program and the class file. The class file is pencil. If I type in Java pencil, it's not going to run actually because I just deleted the class files. Let me clear this for a second. Alright. So I have them both in the same directory, and I want to take a shortcut method. I've decided I want to run, if I run pencil, it's not going to work for me. We've seen that already because we have no main. And we know that main's inside of create pencil, and that's the program that we're going to run. So I can take a shortcut method. This is what I wanted to show you, which is what Eclipse does if you don't save the files, which is why you always want to save something after you change it. Because unless there's a change to something, there's really no need to recompile something. So if I just say, well, create pencil's my main program, and I just go Java C create pencil .java, I come back and I say, oh, that's interesting. Oh, look at that. I got now a pencil too. So the shortcut method is to go through and just compile the driver, and it will go through and compile everything else. However, caveat here, if I make a change to create pencil, and I save it, and I recompile it, and it already has a pencil out here, it's not going to recompile it. I'm going to get an old pencil, even if I've changed the pencil.java source code. So, as another caveat, in terms of best practice, if you're making changes to a lot of class files, remove all the class files, compile the driver, and it will recreate everything for you. And it will also make sure you have everything there. Because if pencil is missing, when I compiled create pencil, it would come back and give me an error message. Say, hey, there's no pencil. We need pencil. Which is sort of what the Visual Studio does when you compile the package. It goes through and looks for all the dependencies and everything. Eclipse will do the same thing as well. I was just too lazy to go back and do it in Eclipse. But the same behavior works. And the only problem is when you have those windows open, this is what I wanted to illustrate to you. I'm out here in Eclipse. Where's Eclipse? There it is. And I got all these windows open, and I've made all these changes to all of these files. And I go and I compile. Well, none of them got saved. All of the old stuff is going to be running for you. Which is why I always like to go through and, okay, close that one, close that one, close that one. because it'll give me that message that says, hey, it's not saved. Would you like to save it? So, yeah, because this one, nope, oh, I guess I saved them all. But long story short, there are a few of those little things, and I'll try and point them out as best as the ones that I've discovered. There's other odd things that occur as well, but like, you know, any IDE, it's not 100% perfect, but it does save you time from having to go to a terminal prompt. So, all right, I think at this point, it's time to take a lunch break, and then we're going to come back. I'm going to go through, two, maybe one more lecture and finish this one. This one's not quite done yet. And then look at some more examples. And then we're meeting tomorrow. I always have to announce this before lunch, because I'm going to lose half of you at lunch. Unlike in the past where we may have only met on one, we're actually meeting on 2 days. We're meeting today, and we're also meeting tomorrow. And we're meeting at 10 o'clock in the morning. So some students show up half day today, and then they leave, and then they show up tomorrow, maybe, hopefully. It'd be nice if you showed up tomorrow, because you'll get the second half. We're not going to finish today, is what I'm saying. We're going to have 2 days. Starts at 10 o'clock tomorrow. Let's take maybe, what do you think, an hour? How long do you guys want for lunch? An hour? Yeah, okay. So it's 12:20, well, let's just call it 12:30. 1:30 when we come back. We'll go till, just in case you're wondering if you want to come back, we'll go till 3, 1:30, 2:30, we'll go for like another couple hours. 1:30, 2:30, 3:30, yeah. No? Don't do it? What did you say? Don't take lunch? Only half-hour lunch? No. Don't go? 3? 3's enough? Okay, I'll get you out by 3. I promise I'll get you out. If you come back, the reward is you're going to get out by 3. Yeah. All right, very good. And then we'll pick up, and we have plenty of time tomorrow to finish everything else. Great. All right, enjoy your lunch.